Therefore, we are going to combine our quizzing with Learning Targets 10 and 11 together. This is the last piece of our solving equations lessons before we truly get into just using the solving equations for every other purpose when it comes to algebra and working with what we need to know for algebra. So today we're talking about solving literal equations. And what we mean by a literal equation is an equation where variables represent known values. For example, d equals r times t is one that you will see often in science class, where d represents the distance traveled, r is the rate or speed at which you travel, and t is the amount of time you spend traveling. Another example that we will see quite often in algebra this year is y equals mx plus b, where m represents your slope. Don't ask why they use m, I have no idea. B represents the y-intercept, same thing there. And x is any x-coordinate that you put in, y is any y-coordinate. So what we're going to actually do today when we talk about solving literal equations is we are going to take an equation that has a bunch of variables, sometimes numbers in it, and we're going to solve for one of the variables, letting the other variables still remain unknown. So how do you solve a literal equation for one of the variables, you ask? So what we're going to do is we're going to take a look at this first one. I have solve k equals c plus 273 for c. This is actually an equation you will see in science class, where C represents the temperature in degrees Celsius and K is the temperature in degrees Kelvin, which Kelvin you only hear about in science class. And I want to solve this for C. So what I would actually do here is instead of saying I pretend like I have a value for K and we need to solve it for C. Well, to undo and get C by itself, I need to get rid of this plus 273. So to do that, I'm going to subtract 273 from both sides. So which leaves me, after I cancel out the 273 minus 273, I'm left with C on the right-hand side. Now, I can't subtract 273 from K, so I'm going to just leave it as K minus 273. And that is it. K minus 273 equal to C is what we're looking for. So let's try another couple of examples. The next one I have is solve x equals 5y for y. Now normally we would have some number in there for x, but because we don't, that's okay. And we say, well, what's being done to y? In our case, y is being multiplied by 5. Now to undo that, I'm going to divide by 5 on both sides. So I do that, which cancels my 5's here, leaving me with y. And I can't actually divide x by 5. So instead, I'm going to take and just write x over 5 equal to y. Now, if you would like to make a side note that x divided by 5 is also acceptable, please do. Because it is correct that you can choose to use the division sign instead of a fraction bar. But bottom line is, this is what we are looking for. So let's try another example. We have here solve 3m minus 7n equal to 9. Now this one is just a little bit more complicated because we've got a few more numbers and a few more variables. And I apologize, this should actually say 4m. I'm not sure why it got deleted out of there. So if we want to solve 4m, if we think about back to planning, I would normally, if m were my variable, I would first multiply by 3, and then I would subtract 7n. And I'm going to leave n there as if we know what n is. So when we do our U-turn to solve, it's actually going to end up being, I'm going to add 7n, and then I'm going to divide by 3. So when I go ahead and do that, I will add 7n to both sides, which cancels here, leaving me with 3m equal to 9 plus 7n. Now, according to my plan, I said that I'm going to divide by 3. So I'm going to divide by 3, again, on both sides, like we've been doing the whole unit, canceling my 3's, leaving me with m, what we're equal to, which is what we're trying to solve for, 9 plus 7n all over 3. And this would be our solution. So now we have time for one last example. This one looks a little bit more complicated. We have solved v over w equal to 9, which looks simple enough, but we're solving for w. Now if you'll notice, w is in that darn denominator. So it makes it a little bit more difficult. We have a little bit more work to do. So I'm going to start off by writing v over w equal to 9. Now, I know we're solving for w, but because it's in the denominator, we need to start off by multiplying by w on both sides, because we want to get that thing out of the denominator. It's like we're clearing the denominator, just like we did with fractions. So now we've got v equal to 9w, and that looks a little bit more friendly. So we're going to divide by 9 on both sides, canceling those 9's, and gets that w by itself. So we have w equal to v over 9. And so therefore, that is all we need to do. So what I need you to do is to go ahead and solve the U-try problems of a plus 3 all over b equal to c for a, and 6 equals 7j plus 8k for j. Please bring any questions, which I have a feeling you will have quite a few of them, and have your summaries written to the best of your ability for Monday. Don't forget, we also have a quiz on Monday.